Hi, this is Saurabh and I am going to show you how Bytebell Spec decreases the cost of AI by more than 90% while keeping the accuracy same, or in some cases increasing the accuracy of even SOTA models. So the question that we'll take is basically from SWE-bench Pro, and one of the repositories Totao. There are total 11 repositories, and every commit of Totao repository will have a question attached to it. So for an example, this is the commit hash on which we will test Claude Opus 4.8 without the Bytebell MCP and MiniMax M3 with the Bytebell MCP. Now, and both these sessions are 15 minutes long, so I'm just sharing the results with you and the logs update. So we have taken, so Bytebell is a platform on which you can ingest any number of repositories, any number of files, and we generate a spec layer that answers which code is connected to what, and which function is exporting, importing, what's the cross repository dependency, what's the blast radius, everything that is related to semantic analysis of the code. So we have already indexed this repository, analyzed it and created a spec layer on top of it and stored it in a database which is exposed through the MCP protocol. So now these are the questions. For an example, I can show you, this is the data set, this is totao.gc. So this is instance ID, this is the base commit that I have just shown you, and this is the patch. Now the patch generated by both these windows should be approximately same, so that it can pass, the patch can pass all the test cases listed in this question. I have not made this is the open source, so requirements are there, interfaces are there, and then you have to fail to pass and pass to pass all these test cases. Now so we started with this, execute this, and the agent file that I have used to actually run both these agents is this. Run eval agent task SWE-bench Pro evaluation. There are two arms, one is arm A, this is arm B. Arm B, it runs without the MCP server, and arm A, let's just a second. So I can't see the question though. Just a sec. What? Okay, I've taken it, I've branched it. This is open code. So this started with, and then because this is not allowed to use MCP, what it will do is it will download the repository, check out that commit hash, and then do a brute force search using the tools like grep, find, sed, awk, these tools to actually find the particular code snippets. See, edit type refs, edit type models, and this is Claude Opus, fable, and then entity rest client. At the end, it generated and it passed. See, this is the evaluation. Attempts 1 failed to pass. 108 tests was there, and 108 of them it has passed. It took $10 approximately, right? And you can see the analysis. In this open code, we have the access to localhost 3100, which is the MCP protocol that has the Bytebell spec layer stored for this commit hash. Now it started. Now it's establishing the connection, and because open code cannot call the SSC directly, server side streamable HTTP, it made a proxy by itself, and this is the MiniMax M3 open router. Availability of MiniMax M3 open source model. So it did, and then it started again. Now it's calling the MCP tools. You can see that localhost 3100. It will keep on calling locate fix files by Bytebell IR graph. This is intermediate representation commit hash. Now it will go on and on and on. IR search files, 2 files found, then there is a query, then it made a request to again the MCP server. In total, it will make around 40 MCP calls, and then it generated the patch, right? And then it wrote the patch, applied it and tested it, And at the end, it also check the disk space whether whether it can download the repository or not. And at the end, it generated this huge file, and these are the results. Let me show you. So the result is, verdict: failed to pass 100 test suites. It said 108, but there is a difference of only one. It passed all the test cases, right? And passed. There are no P2P tests, nothing to break, as we saw. Per assertion, I cannot construct a single F2PA that my patch fails and no P2P exists to break. Verdict: 107 pass test pass entirety, all the changes that were required. Cost to telemetry, this doesn't have access to open telemetry, only this has, so it basically couldn't use it. But then you can see the total cost is $0.72, which is almost 95% less than $10. And then these are number of tool calls: retrieve 15 files it retrieved, 10 classes or functions it searched, list knowledges, search files, file overview. And how the MCP was used also written. File in this evaluation, it also provides the files that it used to actually make the assertion. So now it has been proven that Bytebell MCP actually makes the open source model as comparable to SOTA models with 90% less cost. Thank you.